Let's say I'm asking you on the test to give me the effective nuclear charge for an element. And let's say this element, this element is oxygen. Okay. So if you look at oxygen, and if we were to do it the traditional way, it's 1s2, 2s2, and then it's 2p4. Okay, so this is my first energy level. This is my second right here. So, well, you have to ask yourself, well, what is the atomic number? What is the nuclear charge? In the nucleus, how many protons you have? And if you look here, you have 8. That's 8. So you say, okay, 8 minus, you have 2 in the first energy level, which gives you what? Plus 6. So it's plus 8 minus 2 gives you plus 6. The reason why is because these are in the second energy level. So the effective nuclear charge, Z effective, is plus 6. How would we draw it? Well, here's your nucleus. It has a plus 8. First energy level, first shell has 2 electrons. So what charge do they experience? So these in n equals 1, or the 1s, basically the orbital, the first orbital, they have that 1s orbital, they experience a positive 8. So they actually experience the full charge. They're like the Secret Service. But the ones on the outside, so the second energy level, has 6 in it. So what do they experience? They experience 8 minus 2. And these are the plus 2. So they experience plus 6. While the ones on the inside, these experience the full positive 8. Okay, how do we get the effective nuclear charge? But you should be able to, based on the, if I ask you what is the effective nuclear charge for example, any of those, you should be able to subtract from the previous ones. So let's actually look at this. So let's look at another example. Let's say I'm asking you to give me the effective nuclear charge of Si. Okay. So you're asking yourself, well, what do I have? Well, if you were to do the electron configuration, it would be 1s2, 2s2, 2p6, 3s2, 3p2. Okay. How would we draw this? Well, let's look at silicon. Silicon has a positive 14. So that's the nucleus, has 14 protons. First energy level, the 1s right here, has 2 electrons. So they experience the full plus 14. The second energy level, which is this, that's again what the 2 means. Again, be careful not to disregard what those numbers mean. Those numbers, again, mean the energy level, and they are an integral part of the bonding of everything to come. So understanding what those numbers mean is crucial. So that's the second energy level. They go here. Now, of course, there are 8 of them. I'm not going to put all 8. So I'm just going to say, you have 8 electrons. And then the third energy level right here has 4 electrons. So you would say, okay, I have 14 minus 2 in the first one, 8 in the second one, and that gives me a plus 4. Okay, well, what is a quick way of doing this? Here it is, very simple. Go with a group number. See this 1, that 2, and then jump here. We're not going to worry about these for now. This is, so you continue counting. This is 3, or you look at the second digit. Or you can look at this 3, the Roman numeral, 3, 4, 5, 6, 7, and then 8. Of course, hydrogen and helium, they're 1 and 2. So this is a plus 1, and that's a plus 2. Okay, we did what? Oxygen, phosphorus, and silicon. Is there a quick way of getting the effective nuclear charge? Yes. All you have to do is just look at this number on the top, which we're going to use when we get the valence electrons. Phosphorus right here is in group 15, or 5A. So I look at this digit right here, the 5. Let me make this a little bit bigger. The 5, or the Roman numeral 5. And it's just going to be plus 5. So the ZEFF, Z effective for phosphorus, is plus 5. Okay, silicon. We just did silicon. Well, let's look at it. Silicon is in group 4, or you look at the second digit, and it's plus 4. Isn't that what we did here? Here it is, plus 4. Oxygen, we just did it. Well, when we did it, we got plus 6. Here it is, 6, or this digit. So that's a quick way. But of course, I spent time going over the theory because this is very crucial. In fact, some of the terms that we're going to see later are actually based on this.